Hello everyone, welcome back to my YouTube channel again. So in this video, let's solve problem number 3b from model question paper. That is, find Thevenin's equivalent terminals A and B at this Thevenin equivalent circuit you have to draw. To draw the Thevenin equivalent circuit, you need to find the value of VTH or VOC. Then you need to get the value of RTH. But there is a dependent source, so that to find the value of RTH, you need to find the value of VTH or VOC divided by I short circuit current. Means you need to short circuit this terminal. So now to find VTH, that is nothing but here, this is VTH. Now we need to find the value of VTH or VOC. So either you can use nodal analysis method or loop analysis method. So here I'll use loop analysis method. So I'll just giving the loop direction. Okay, so I1 is flowing here and I2 is flowing here. Then you need to find the value of VTH. So before that, now apply KVL. Apply KVL to loop I1. Before that, you need to write Vx. What is Vx? Vx is nothing but 3 into I1. 3 into I1 is Vx. As the current direction is also from plus to minus, so that 3 into Vx. So now apply KVL at loop 1. Before that, there is a super mesh. Before applying KVL to loop 1, there is a super mesh. From super mesh, you need to write one equation. From super mesh, 10 amperes equal, that's nothing but, you can see, I1 minus I2. 10 amperes equals to I1 minus I2. Okay, whereas I2 is nothing but Vx divided by 4. This is I2. Okay, Vx by 4, and Vx equals 3 into I1. Therefore I2 is nothing but 3 into I1 divided by 4. So you can write here 10 equals I1 minus 3 into I1 divided by 4. You can get the value of I1 directly. So that is nothing but 10 equals I1 minus 3I1 by 4. You can use 4I1 minus 3I1, that is nothing but I1 divided by 4. Therefore I1 equals 4I1 minus 3I1, I1 divided by 4. Okay, so you can get the value of I1 as 40 amperes. Okay, so now you can get the value of I2 directly, and we know that I2 equals 3 into I1 divided by 4. That's nothing but 3 into 40 divided by 4. You can get 4 ones are 4 tens. I can get I2 equals 30 amperes. To cross verify this, you know that 10 equals to I1 minus I2. 40 minus 30 is nothing but 10 amperes. That is a cross verification. Okay, so now we know the value of I1 and I2. You can get the value of VTH by neglecting these current loops. Super loop. So now this is a super loop. You apply KVL to super loop. Apply KVL to super loop. So you can get the VOC or VTH equal sum of all these drops. Sum of drop across 5 ohm, 3 ohm, 3 ohm. So 5 ohm across drop, there is a Vx by 4. The current flows, this is Vx by 4. Therefore, you can write also I2. We can say it as 5 into I2 plus 3 into I1 plus 3 into I1. 5I2. I2 is flowing here. 5I2 plus 3I1 plus 3I1. You can get, substitute the value. 5 into I2 is nothing but 5 into 30. 150 plus 3 into I1. 3 into 40. 120 plus 120 you can get VTH equals 150 plus 120 plus 120, you get 390 volts, that is VTH. Now you need to find the value of IN. So before that, you understand once again, Vx you are writing, this is Vx, then you need to find the value of RTH. To find the value of RTH, first you need to find VTH, then ISC. ISC means short the AB terminals. So now you'll get I1 as a 40, I2 as 30, VTH as 390. So now to find IN, to find IN or its ISC, sorry, to find short circuit, short the terminals A and B, therefore the circuit becomes like this. This is a circuit. The terminals A and B is shorted now, and current flows to this is ISC. This current you need to find the value of RTH. 3 ohm plus and minus Vx, they are only given. 3 ohm, 10 amperes, 5 ohm, and the direction is upward, and this is Vx divided by 4. Same thing, I1 is flowing here, I2 is flowing here, and I3 or else ISC is flowing here. I am giving the same direction of ISC. Okay, so now use loop analysis method. Before that, two super loops are there. From first two super mesh are there, 10 amperes and Vx by 4. Therefore, from first super mesh, that is 10 amperes. 10 amperes equals I1 minus I2. Okay, you can also rewrite it as I1 minus I2 equals 10 amperes. This is equation number 1. Whereas Vx, you already know, Vx is nothing but 3 into I1. Vx is 3 into I1. Similarly, from second super mesh, so you can write Vx by 4. Vx by 4 equals, both are in same direction, therefore I2 plus ISC. Whereas Vx is nothing but 3 into I1. 3 into I1 divided by 4 equals I2 plus ISC. 3 by 4 is nothing but 0.75. 0.75 I1 minus I2 minus ISC equals to 0. This is equation number 2. Okay, so now if you apply KVL to super loop, so this is your super loop. This is a super loop. Apply KVL to that. So if you're applying KVL to super loop, 0 equals, okay, so I will write now, apply KVL to super loop. Okay, so 3I1 plus 3I1 plus 5I2 equals to 0. 3I1 plus 3I1 plus 5I2 equals to 0. So you can get 6I1 plus 5I2 equals to 0. Drop across all these you are adding super loop by neglecting these two. Okay, this is equation number 3. Now we can solve the equation with the help of calculator. Keep your calculator in equation mode. 3 unknowns are there. You can see the first equation, I1 minus I2, that is nothing but 1 minus 1, ISC is 0, then D1 is 10. Similarly do it for next one, 0.75 equal minus 1 minus 1 0. Similarly for third equation, 6 5 0 0, you can get I1. What is the value of I1 now? I1 is 4.5454 amperes and I2 is minus 5.4545 amperes, but I want ISC. ISC equals 8.8636 amperes. So now RTH is given by VTH divided by ISC. VTH is 390 and ISC is 8.8636. Sorry, 8.86. I'll read it now. 390 divided by 8.8636. You can get the value of RTH. 390 divided by 390 divided by 8.8636. You can get 44 ohm. That is RTH. Now you draw the equivalent circuit. RTH, VTH across the terminals A and B. RTH is 44 ohm, VTH is 390 volts. This is the solution. If you want, you can take screenshots. Okay, so this is about the question number 3B from network analysis. If you're having any doubts regarding this, feel free to write in the comment box. Thank you so much. Have a nice day. And if you really like this video, kindly do subscribe and share maximum. You should draw this network. Okay, thank you so much. Have a nice day.